So we have done so many factoring, learned so many factoring methods over the last couple of days that sooner or later we're going to have to combine all of them together, which is the point. So some of the expressions or equations we might be looking at now may not just be ready to be completely factored within one step or so, or one factoring method. So what we have to do is be able to recognize what certain expressions look like and how they're supposed to be factored. So what I've done here is, I think this is also a good review to go over all of the different methods that we've learned so far. And so in the black box that I have right here, at the top of the screen, I have the several factoring methods that we've looked at so far, and the corresponding formulas for them. So the one I want to point out, which is the one that's typed, is the factoring by pulling out the GCF. This one, in number 1, I'm going to put lots of little stars next to, because it's the one that people usually overlook. And so if you don't know how to factor something at first, it's usually because there's a GCF that needs to be pulled out. So check for that first, and then after that you can identify maybe which out of the remaining 2 factoring methods it looks like to be able to continue on with the problem. So let's work on some problems, and I'll try and leave this box up for you guys to refer to, but write it down. Maybe pause the video so you have some time to write it down. And let's start looking at some of these problems. So for number 1, the directions for this first set of problems is just a factor, okay? So let's go through and look at this. So let's just go through every step here. So my first way of factoring is by pulling out a GCF. So looking at this number 1, does this problem have a GCF? Do these terms have a GCF? They do, right? Their GCF is 2. Okay, so I'm just going to write this. If you don't need to do this step and you can see it right away, be my guest, you can skip it. For those of you guys that can't, that's perfectly fine. That's why I'm doing it this way. Okay, so we have the GCF. Remember, once we figure out what the GCF is, you can rewrite the problem. And you want to divide everything by what the GCF is. Okay, so what that would be is, for this first term, the 2's cancel out, so I'm left with p squared. And then 40 divided by 2 is 20. Drop that p down. Plus 200 divided by 2 is 100. Okay? And then remember, I put that in a parenthesis and write my GCF on the outside. And so what happens here is this inside can be further factored, okay? And the way that this looks like is, out of these last remaining ones, which does that look like the most? It looks like the first one from number 3, just like the one we did yesterday, right? So since this is a minus sign as the first sign, I know that my final parenthesis is going to have a minus sign in it. Okay, so I go minus, oops, not minus, so close there. So I put a minus sign in the middle there, and put a squared. Don't forget my GCF, I just dropped that down. So remember, whatever goes in this first one is the square root of this guy, which is p. What goes in the second slot is the square root of this guy, which is 10. So my final factoring for this is 2 times p minus 10 squared. Okay. So more than one factoring, combined factoring is what we're doing today. Number 2, let's go ahead and look at number 2. So let's first check if it has a GCF. Okay, so GCF for these guys, believe it or not, is 3. So the 243 might have been a tricky one. So what I do is, let's rewrite the problem and divide everything by the GCF. Okay. When I do that, I'm left with, in the first term, a squared. The second term, I'm left with 18. And then the last term, I'm left with 81. Okay. Put that in a parenthesis, put our GCF on the outside. If I was to simplify this, it looks like, again, number 3, the first equation. So since this first sign is minus, my parenthesis is going to be minus. Okay. Put my GCF on the outside. Square root of a squared is a, which goes in the first slot. Square root of 81 is 9, which goes in the second slot right here. And then, so our final answer for this is 3. Oops, that is not very straight there. Okay, it's 3 times a minus 9 squared. And it looks just like that, okay? Let's just keep practicing with these. Again, if you guys have some questions, please write them down so that we can go over them tomorrow, okay? Here we go with number 3. And I got a 4 and 5 down there, so you can start to see. Okay, so let's see first. Do we have a GCF among all of these things that we have here? Okay, the GCF for this, there is one, and it's 5. Okay, so let's rewrite our problem and put them all over 5. So when we simplify all of this out, I get, in the first term, 25n squared minus 40n plus 16. Put that in a parenthesis, put the GCF on the outside, and then, let's see, this also, again, looks just like number 3. Oops, let's scroll up here if I can do this straight. It looks like number 3 here. The first equation again, because since the first sign is minus, this guy is going to be minus inside too, so just like what we've been doing here. So I'm going to put a parenthesis, draw a parenthesis, put a minus sign since this first sign is minus, squared on the outside, put my GCF on the outside of the parenthesis, and I get 25 squared. 25n squared is 5n. 16, square root of 16 is 4. So, final answer for that looks just like that. 5 times 5n minus 4, and then squared. Okay, hopefully you're getting the pattern of this. Let's look at 4 and 5. 4 and 5 are a little different. They have some variables that are more variables than the ones we've been doing in 1 through 3. There's 2 now, okay? But you treat it the exact same way. First step, let's see if we have a GCF, and then second step is to match it up with the correct factoring method, okay? So, let's see if we have a GCF here. So for the numbers, we have a 25, an 80, and a 64. So thinking about that, I don't think any of the numbers are going to have a GCF. Let's look at the A's. I have a squared, a, but I don't have an a in the third one, so for it to be a GCF member, all of the terms have to have it, so a does not have a GCF in this one. But oh, look what I have here. I have b's in all 3 of them, okay? And they all are b squared, so their GCF for this is b squared. That's the only thing we have. So let's rewrite this. Okay, and let's divide everything by the GCF. And looking at this, as smart math students as you are, you could see that all the b squareds actually are going to cancel out. So these go away, so we basically just have everything left over without the b squared. And again, we drop our GCF on the outside of this parenthesis. Let's look at what's inside. Again, looks like a number 3 factoring method, the first one. Why again? Because we have that silly minus sign in the front. Okay, so put a minus there, put my square on the outside. Here's my GCF. So square root of this first thing is 5a. Square root of the second thing is 8. So final answer for this looks like that. So why don't you guys try number 5, and then let's see how you do, and I'll put the work here, and we will check and see how that goes, and then we'll move on to number 6. Final answer for this one is 2x, and then in a parenthesis y minus 3 squared. And I just want to point out here that all the examples we did were minus signs, but for example, if maybe for number 5, let's say this started out as a plus. Okay, all that changes here is that this became a plus, and because this was a plus, because this first sign was a plus, that one would end up changing to a plus. Okay, so just be flexible. Again, the first sign when you are dealing with these trinomials are really what's going to dictate what the sign in the final parenthesis is going to be. Okay, so just watch out for that. So I'm sorry I gave you all examples that are all minus signs, but remember, whatever this first sign is in a trinomial, that's what's going to go into the parentheses. I want to end this video by doing one different kind of problem, since we've been doing a lot of factoring, and I want to combine it with some older stuff that we've done. Okay, so directions for this is to solve basically and then check to see if the answer is correct. So to solve this, now that you guys know how to factor, remember when we're solving, what that's going to tell us is we're going to have an x equals and then some number. Okay, so our final answer should look like an x equals some number. So what I would recommend is let's take care of just this left side first and take care of everything we can possibly do with that. Then let's work on the right side, and at the end, once we've done as much as we could in each side of the equal sign, we'll put them together to try and get a final x equals statement. Okay, so just looking at this left side, the 2x plus 5, this looks like the stuff we did yesterday, remember? Okay, where this guys are A, this guys are B, then because this is a plus sign, that means that's what our first sign is going to be. Okay, so here we go. Plus and plus. Okay, don't forget plus and plus because we have first sign is plus, so the parenthesis sign's plus, so the first sign's plus, and the second sign's always plus. Okay, so how this works is we go A, which is 2x squared, plus that 2 that's always there, and then A is 2x, B is 5, then this last thing here is 5 squared. I'm just going to put this equal so I don't forget I have to work on some stuff on that other side. I'm going to simplify this the best I can. Don't forget that 2 goes to the 2 in the front, so 2 squared is 4, x squared plus 2 times 2 is 4, times 5 is 20, x plus 25, and that's as much as we can do on that side. Okay, let's work on this right side now, same idea. Here's my A, here's my B, first sign is plus, so I have plus and plus. A is 2x, middle term is going to be that 2 that's always there, times 2x times 3, last term is 3 squared, so let's simplify that. Okay. 2 times 2 is 4, x squared plus 2 times 2 is 4, times 3 is 12x, plus 9. Okay, so now our goal when we're solving is to get all of the x's on one side and all of the non-x things, or all the numbers, on the other. Okay, so let's move, let's move this 4x first. So I'm going to subtract 4x squared from both sides. And what happens to that? Apologize. What happens here? So we have these two guys cancel, these two guys cancel, so I'm left now with 20x plus 25 equals 12x plus 9. Okay, almost there. Remember, I'm trying to get all my x's on one side, so let's move this 12x over. So we're going to subtract it over. This side cancels. 20x minus 12x is 8x. Okay. Last step here, what are we trying to do? We have to get our negative 25 over, because we have all our x's already on this left side, so let's move this 25 over by minusing it. 25's cancel. 8x equals negative 16. To get rid of that 8, divide 8 on both sides. So x equals negative 2. Okay.